Hello and welcome to another episode of Earth911's Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society. And I'm your host, Mitch Ratcliffe. Thank you for tuning in. Plastic recycling has stumbled through a slow evolution and created a lot of distrust amongst consumers and government. Chemical, molecular, and enzymatic plastic recycling have all appeared in the last several years, with promises that plastic can finally be turned from a linear, waste-creating system that fills landfills with pollution to a circular economy that keeps all, or virtually all, of the plastic we use in circulation without the need for virgin plastic made from oil. Our guest today is Emmanuel Ladent. He is CEO of Carbios, a Clermont-Ferrand, France-based company that has developed an enzymatic plastic recycling technology. Carbios' technology recycles polyethylene terephthalate, or PET, also known as plastic number one. Plastic number one is the basis for making billions of single-use bottles and thermoform containers like the ones that produce come in, as well as polyester used in clothing. About 2/3 of our clothing is actually made from plastic, and half of that material is polyester, according to a 2021 Maastricht University study. Plastic number one is a ubiquitous pollutant that has been recycled at very low rates because the process has not proven to be consistently profitable. I spoke with Emmanuel a couple of months ago and was impressed by Carbios' approach. We'll talk about the details in a moment. But if we can recycle PET efficiently and create the infrastructure and consumer habits that support recycling PET at scale, it would be a huge step forward towards a circular economy. So let's dive into enzymatic recycling. Welcome to the show, Emmanuel. How are you today?
Thank you very much, Mitch. I'm very well, thank you.
Well, it's good to be talking again. When we first spoke, when I was learning about what Carbios is doing, you had issued a report in 2020 that said you were recovering about 90% of the plastic you recycled. That's almost on par with the way that aluminum performs. How have your yields changed since then, and what's your recovery rate today?
Yeah, we are pretty much above that right now. We are above 90% in our demonstration plant installed here in Clermont-Ferrand. We are doing still some optimization to go beyond the 90%. Our target is to go quickly to 95%, which will allow us to claim that we can recycle the same material 20 times. And at the main part of the process where we meet the waste of PET, the PET waste and the enzyme, in what we call the hydrolysis phase, we are already above 98%. So we are progressing on that, and our target is to go as much as possible, as fast as possible, to 95% in the full process. So basically, from 1 ton of PET, we want to achieve 950 kilos of PET reproduced at the end of the process, which is very high in circularity compared to any other recycling process.
Well, and so there's a lot of skepticism about plastic recycling. So tell us how this has been independently verified. What kind of juried research and other kinds of validation have you worked to accomplish?
Well, so we work with a lot of industrial partners. So first, from an engineering standpoint, our partner is Technip. It's a very large group, which is worldwide recognized. Now we work also on our LCA calculations with a company named Deloitte, which is very famous and very clear. Our process has been audited and checked by the European Bank of Investments before they granted us a loan at the end of last year. Last but not least, the main plastic producer in the world, Indorama Venture, has audited and made a very significant technological due diligence on our process in the last 12 months. So all the figures I'm telling you are verified by third parties of major importance.
Okay, so let's talk a little more about what it does and how you do it. PET has been a very problematic recycling process because different types of PET can't be mixed together and so forth. How does the Carbios process work? Do things need to be separated into different types of PET, or it can all be put in one process at one time?
Yes, that's really where we bring the major disruptive innovation. We can bring any kind of PET waste inside our depolymerization process. So basically, we can process bottles, colored bottles, which are today mechanically recyclable. So in our process, but more importantly, we take, and it's going to be a major part of our feedstock. We take food trays. Most of the food trays we use in the world are not recyclable, and they are incinerated. So we are taking that. We also take everything which comes in from the cosmetic industry, which for most of those packaging are not recyclable today.
Yeah.
And the polyester fibers, which are which is the main source of future feedstock for us, which is all the fibers we find in the sportswear industry, or in a lot of apparels and textile industry. So all of that is PET, and because we use enzyme, and our enzyme works the same way on a bottle, a food tray, or a polyester fiber. So that's much more flexible than the current recycling technologies.
Well, another limitation on current recycling technologies is that they can't process colored plastics, like a black food tray made of PET. Carbios does?
Yes, absolutely. In our process, whether it's colored bottles, colored food trays, or colored textile, we eliminate the pigments of color in the process. So we really, the process, we take any kind of PET waste, and we go back to the two basic components of the plastics, of the PET plastics, which is used by 97% of the capacities in the world of PET production, which is the terephthalic acid and monoethylene glycol. So what we produce is terephthalic acid and monoethylene glycol, totally compatible with the existing industry of PET production, and we can take any colored waste or any transparent waste in the process. So we can blend the waste. That's also the big advantage of our technology. So basically, in our process, we can process a mixed food trays, bottles, and textile at the same time. In terms of processing, the enzyme is non-selective on the support. It's going to do the work, do the job.
So you can extract the pigment. Are there any other residual materials left that are potential pollutants, or is everything literally reused?
Most of what we extract from the process is going to be pigments, color pigments. In our process, we get a residual waste which we call a filtration cake, and that's a very good energizer for the cement plants, and it's about 2% of the income. That's why we are not at 99 or 100% PET conversion. We have this 2% of pigments and sometimes small non-PET elements, which is filtrated in the process and which will go to provide energy in the cemeteries.
Oh, that's it. Okay, that's interesting. So what you're saying is that when we talk about the yields from PET process, there is some other materials in there that represent part of the volume.
Yes, absolutely. Yeah.
So it's not necessarily that you're not processing all the PET, it's that not all of it is PET.
Yeah, absolutely. You're absolutely right.
So how does this process differ from chemical and mechanical recycling in terms of, for instance, energy and water use, or the temperatures that are involved, which of course require more energy?
So first before we process, we have the collection and the sorting. And for mechanical recycling, you need a lot of sorting and a lot of washing of the waste. Because, for food grade homologation, when you do mechanical recycling, you need to wash a lot the waste. We don't need that. I mean, at Carbios, we can use a waste which is, of course, washed one time, but does not need to be washed several times, and does not need to be overly sorted, because if you have a mixed bag of bottles and food trays and textile, we can process it. So we don't need so much sorting and so much washing. So we do savings on the upfront. We do savings during the process because we use less energy. Our enzyme works in 70 Celsius, so it's about 150 Fahrenheit. At 150 Fahrenheit, while other processes works above 400 Fahrenheit, 400 degrees Fahrenheit. So we are in a process which is lower in terms of energy consumption. And on the back end of the process, when we stop, we produce two monomers, terephthalic acids and monoethylene glycol, which are totally compatible with the existing industry. So we also do savings to the planet, because we don't need to rebuild the plants which will produce the plastic by merging those two monomers. We are compatible with the existing plants. So we have a huge, I would say, planet impact by not rebuilding the industry, but being compatible with the existing industry. And that's a big difference with the chemical industry, with the chemical recycling. In chemical recycling, particularly in methanolysis, you produce not terephthalic acid, but another monomer, which we call DMT. And the DMT has to be repolymerized in a new plant because there is not any longer capacity for DMT in the world.
So making the monomers, you're making the feedstock that you used to have to refine from oil to make plastic.
We go back.
Reducing the need for refinement as well.
Absolutely. And the plastic is about 5% of the oil we use on Earth. So our intent is to contribute to the reduction of oil consumption by the circularity of our recycling process. The last but not least, the difference between mechanical and chemical is circularity. In mechanical recycling, you do a few cycles, but then the plastic degenerates to something which is not food grade any longer, and not capable to be for clear bottles, for instance. You go back to a darker kind of plastics. In our technology, we always go back to each time we do a recycling cycle, we go back to a virgin-like plastic, so we can do much more cycles.
So that going back to the idea that some of what we process is not actually PET. When we talk about 95%, we're recovering literally all of the monomers. How many times can those be recycled?
I would not say that. I mean, there is a bit of loss of PET too. I mean, in the gap between 95 to 100, it's, as I said, colors and non-PET, and a little bit of PET that cannot be processed because of time or because of so it's a mix of that. But 95 is the highest in the industry. I mean, there is no recycling.
The point I want to get to is these monomers can be recycled literally forever, not necessarily forever, but there's always a little loss. Does that mean that if we, for instance, started to pull old PET plastic out of landfills, that we could potentially have enough feedstock never to need oil again?
Yes, I mean, we could use landfill PET. We could use PET, which is lost in the ocean. Also, unfortunately, most of the PET in the oceans is not at the surface, but is in has already transformed into either microplastics or has go down in the at the bottom. But any used PET works in our process. I mean, we have done tests. If a bottle is 20 years old or 30 years old, it could be used in our process. So we could imagine that if there was an efficient technology to extract PET from the landfill, we could use it. We could recycle it in our processes. Absolutely.
So this changes the nature of plastic packaging and thinking about plastic packaging. Generally, we think about bioplastics as the solution, but in this case, PET could become a circular material. How do you imagine this will change the way that plastic packaging is designed? Will it need to be produced in a different way in order to facilitate easier recycling?
Well, I think the concept of higher circularity for more eco-conception is going to increase. I mean, if PET gets truly, thanks to our technology, circular, it should be promoted versus other kind of plastics that cannot be recycled in that way. So yes, we believe PET will grow. And it's really going to be important for the brands which are supporting the PET is to be able to claim, and our technology is to be able to claim that they have a true circularity beyond the PET recycling. So I do believe that PET with our technology will we bring to the PET a future with our technology. Absolutely.
So Emmanuel, this is fascinating. I want to take a quick commercial break. We're going to be right back. Let's get back to the conversation with Emmanuel Ladent. He is the CEO of enzymatic plastic recycling innovator Carbios. Now, you've developed a number of partnerships with companies that rely on PET and polyester in their packaging and their clothing. Tell us about the Fiber to Fiber consortium that you launched with Patagonia, On, Puma, Salomon, and now a new member, PVH, which is the parent company of Tommy Hilfiger and Calvin Klein. What are the goals of the organization to create circular clothing?
Yes, absolutely. I mean, those brands are very committed to go fast in circularity of fibers, and they are aligned with us to develop this technology very quickly. So we are doing tests with them right now on doing and intending to do what we do, what we call fiber to fiber. We have done that already in our labs and in our demonstration plant, but we want to do that with their own waste. So basically prove that from a waste, let's take Patagonia, for instance, from a Patagonia t-shirt, we want to do a new Patagonia t-shirt, excluding, eliminating the pigments. And from a blue t-shirt, we could do a red t-shirt. But that's really the processes of R&D that is ongoing right now. Those brands are willing to show that polyester can be a future as well. And unfortunately, today, polyester is not truly polyester fibers are not truly recyclable. I mean, you can find recycled polyester, but it's generally done from bottles. Mm-hmm. So the bottle to fiber is possible from a mechanical standpoint, but the fiber to fiber is not really. And our technology brings a fiber to fiber future to this industry, a true circular way to recycle the fibers.
So would these brands actually start to collect their own clothing in order to process them? Are they interested in capturing their own material?
There are different approaches. I mean, some are willing to do that and collect in their own retail shops their used clothes. But I think the vast majority of used textile will be collected by organism of collection in most countries. So I think we will have to be able to address both ways of collecting. It could be a selected collection in retail stores for certain brands, but it can also work with collective collections for most of the PET we will use in our plants.
And I tend to agree that what we are looking at is a very diverse approach to recycling in the future. But what your technology potentially does is simplify the need for sorting.
Absolutely. We can blend any kind of textile. So we can blend a Patagonia t-shirt and a bottle of Nestle waters and a flacon of L'Oreal cosmetic. And then all of that is recycled in the same way and brings back to the same monomers. But those things we are testing right now is carpets. You know, most of the PET carpets, specifically in North America, are in PET, so are polyester. So carpets is also a market we are investigating to bring the same technology.
Now, you've also partnered with L'Oreal, Nestle Waters, PepsiCo, and Suntory to produce recycled PET bottles. Now, humans used 485 billion PET bottles in 2021. That's going to represent a lot of recycling. How many plants do you need to operate to keep up with the kind of demand that we have just for PET bottles?
The market is huge. I mean, today, unfortunately, only 10% of the PET market is recycled PET. And it's mechanically recycled because our technology was not yet deployed. We estimate that it would be 50% of recycled PET by between 2040 and 2050, let's say. So the market for recycled PET is booming very fast. And if we want to capture the lion's share of this market, we will need plants in all big demographies in the world. So that's our target, is to have our technology deployed in all the big demographies through a licensing process, because of course licensing is faster to deploy our technologies than if we had to build our own plants everywhere.
Okay. So your scale is not dependent on your own ability to raise capital, but on your ability to license to organizations that have the need and the capital to do it.
Absolutely. And in the two main target groups of customers we are looking for licensing our technology, there are industries that needs to shift their investments towards recycling. So the first one are PET producers. The PET producers, they need to shift from petrosourced plastics to recycled plastics, and our technology brings the facility that we are totally compatible for 97% of the capacity worldwide with our technology. So as they are going to invest, we believe they have a strong chance to invest in our technology. And the second big type of customers are the waste management companies, which will have more and more difficulties to landfill and to incinerate waste, and they need to go in other directions. So we believe this is also an industry that will have to shift their investments towards recycling technology like ours.
Now, I read this past week that the European Investment Bank, they issued a report saying there's roughly a gap of euro 6.7 billion to 8.6 billion dollars in funding for recycling in Europe that we don't have a solution for. How do you imagine that funding gap is going to be filled? Do you see the organizations with the need for recycled PET stepping up already, or do we need to put more extended producer responsibility laws in place in order to fund the collection and processing?
Yes, I see all of that. I mean, regulation is going to help. I mean, today the regulation in Europe is 25% of the plastics by 2025 in packaging will have to be recycled, and they're talking to move that up to 65% by 2040. So all of that is helping creating the demand for recycled products. And if we create a demand for recycled products, we create an economy which will be worth. The waste will have a value, the recycling has a value, and at the end of the day, we create a valuable industry which is helping the planet. So that's a positive circular way of creating businesses which will be profitable, but which are also helping to reduce the CO2 and reduce the pollution.
Now, many of our guests have talked about the importance of thinking about the circular economy, not as one big global cycle, but as a lot of regionally oriented circular cycles that connect to the global economy. How big a region do you imagine you'll need to have to justify placing a plant? What kind of, and really, I think my question is, how densely will we need to be thinking about having recycling capabilities in place?
I believe in every big demography, every city is above 1 million inhabitants. Let's say that's where we start to target. Should start thinking of a recycling capability, advanced recycling capability like ours. So in our strategy of deployment, we have two ways of approaching. One is to be close to the PET producers and transport the waste and have the monomers on site. The other strategy is to put our plants, maybe smaller plants, but close to the waste collection places, and do the monomer transformation there and ship the monomers to the PET plant. All of that will have to be at some stage local to local. We cannot start to have to imagine bringing waste which are 1,000 miles away from the plant. I mean, it has to be a close environment, because you want also to not only to we don't want only to generate profit. We want to limit the CO2 we are using to do that. So we have to have waste which are close, a density of population which is there. So we are able to have a local to local approach to the economic. And to reduce the CO2. At the end of the day, it's not only by bringing more circularity, it's also reduce our LCAs and our CO2 consumptions so that we have a sustainable business long term.
Can we create even greater efficiency by co-locating different types of recycling processes together? And have you thought about how to bring your enzymatic process into close proximity so that you could share land, energy, and reuse heat generated by other processes?
Yes, absolutely. Our first plant that we are building in France is co-located close to a PET producer. So absolutely, we share utilities and we share installations so that we limit the quantity of new energy we are generating. We are also looking at green energy for our plants. We are looking at closed water circulations so that we limit our CO2 impact. CO2 is extremely important, not only for Carbios, but it's very important for the brands which are supporting Carbios. I mean, they will not invest in a technology which does not bring a significant LCA approach to their product.
Now, the other end of the process we're talking about is a very volatile commodities market where the price of recycled PET can swing, not necessarily wildly, but it changes a lot. How price sensitive is Carbios' business, and are you targeting a particular price per ton for rPET to support your business?
Yes, rPET in Europe and in the US is already more expensive than virgin PET because the petrol source product is less demanded and the recycled products, there is more demand for it. We believe we will have a premium compared to mechanical recycling, whether it's going to be 30% or 50%, we don't know yet, but there is a premium because we bring more quality and more circularity to the product. Now, at the end of the day, we are talking of a very limited impact for the consumers. Our technology gap for a Patagonia T-shirt is going to be 5 cents. Mm-hmm. The gap on a bottle of sunscreen, biotherm sunscreen from L'Oréal is going to be 3 cents. So we are talking of, yes, there is a price premium, but there is also a very limited impact for the consumers. And consumers are telling us everywhere in the world, but in particular in the US, that they are ready to pay a little premium for sustainable products. So we believe there is a case for change. Now, on the long run, we are also improving our technology. So we believe there is, with time, we will be able to be more efficient in our technology and cross part of the gap with virgin PET. Last but not least, because of our technology is not sensitive to certain waste, but we can accept any kind of waste. We can also have waste sourcing, which brings an economic advantage to Carbios, and make priorities on available waste, which are less expensive than bottles. Bottles are very expensive as a waste, but we can target food trays or textile waste, which are much less expensive.
Now, we talked about the European Union's approach to recycling, but here in the United States, we have a challenging environment, to put it mildly. Do U.S. governments, state governments in particular, need to do more to move the market towards recycled PET, like imposing deposit programs, which have been shown to really increase the recovery rate in the first place, which gives you the more material? As you think about the U.S. market, what do we need to do to get things going in the right direction?
Definitely, I think, and it's very variable by state, but whatever increase the collection of PET and plastic waste is positive. So deposit is a way to improve the collections. Absolutely. We need to have support from the government. Our technology are new. So basically, to install new plants, whether we invest or whether a partner invests, we need some subsidies. Our plant in France is subsidized at about 25% of its capex by governmental programs. So new technologies need support to go faster. So there needs to be a subsidies environment which allows new technologies to grow. And we need a lot of consumer education, because most consumers are not aware that what they put in their yellow bin, for instance, is not going to be recycled. So consumer education needs to be hand in hand with industry to go in the right directions. But at the end of the day, I think we can succeed in the US. There is already a very strong commitment from very big brands, American brands, to go even much faster than the European regulation. I mentioned Patagonia and Pepsi Cola, right. And those brands are very, very committed to go much faster than the regulations.
Are they talking about how to really raise the flag for recycled PET in terms of communicating the values of their products? Are you having conversations about how collectively the industry can communicate the importance of what you're doing?
Yes, I think there needs to be communication on more recycling content. There needs to be communication on circularity, because it's good to say I'm recycling my bottle, but it's good to say how much time it's going to be. So yes, we are talking about the way to market and to inform consumers. And you're right, most of the information will be done by the big brands I have already mentioned.
Now, you recently had a big success in terms of being validated by the French Future program, which was involved in a government subsidy. What steps are ahead for you as you deploy your first full-scale commercial plant, and what's the timeline for beginning to see this, particularly in the United States, because we're interested in it?
Well, we are starting in the US. We have talked in the last few months. We are hiring someone to help us map the market and see where are the opportunities, where are the waste availability. That person is, by the way, coming to visit Carbios next week. So we are starting. We're at the point of starting. We want to license in the US very quickly, because it's a huge market, and we want our technology to be known quickly in North America. So what's
the earliest we can expect to see a plant, do you think? I know you can't make a commitment.
Reasonably, it's we will start in the 18 months to 2 years period, plant construction. So products available in the US, we should be reasonable to say not before 4 years.
Okay. Well,
but that's our goal. That's our goal, to start in the US.
How can folks keep track of what's going on? Because this is going to be a story that's going to evolve rapidly and with a lot of different steps.
we put a lot of information on our websites. We keep communicating on what we are doing, and we will continue to. And thanks for giving us the opportunity to let your auditors know about our technology. So we'll keep you informed, Mitch, about what's going on with Carbios.
Well, thank you, Emmanuel, for spending time with us today. We really appreciate it.
Thank you very much, Mitch.
We've been in conversation with Emmanuel Ladent. He is the CEO of Carbios, an enzymatic plastic recycling company based in Clermont-Ferrand, France. You can learn more about Carbios at Carbios, that's Carbios, carbios.com. The potential for circular plastic recycling is controversial for many good reasons, not the least the long-standing greenwashing by oil and plastic companies. But if society intends to continue to use plastic, we need to use less and keep it out of the environment by improving the collection infrastructure. This enzymatic process that produces reusable monomers, along with the regional approach to circular plastics that Emmanuel described, suggests that the industry could play a role in a sustainable and still very modern society. I'm particularly struck by Emmanuel's argument that any region with 1 million or more inhabitants can and should be thinking about advanced recycling. That suggests that manufacturing will also be more geographically distributed because the raw materials for the next generation of products and packaging will also be available locally. It won't be necessary to ship plastic halfway around the world to be reused. And by eliminating that shipping of recyclables and the feedstock to make new products, we would contribute to lowering society's overall carbon footprint. We'll see. We will see. The plastic industry may be turning a corner, and we'll continue to track the evolution of Carbios and other innovators in this space. I hope you'll take a moment to share this podcast or any of the other more than 380 interviews that we've produced on sustainability in your ear. If you'd take a moment to write a review on your favorite podcast platform, it'll help your neighbors find us. You folks are the amplifiers that spread more ideas to create less waste. Please tell your friends and family and coworkers that they can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other purveyors of fine podcast goodness that you love. Thank you for your support. I'm Mitch Ratcliffe. This is Earth911, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.